All right, let's round out the last example that we'll do in this half of the lesson. We are finding the zeros for the given function. This one is not factorable. We're not going to use our graphing calculator. That takes us to our rational root theorem, which is figuring out our p's over q's, what those possibilities are. In a previous example, I mentioned, hey, if our p and our q values, if those happen to be prime, either one of them, in this case both, then that really reduces the possibilities that we're dealing with. So our p value is 13, and our q value is 1. So the factors for 13 are simply 1 and 13, and our factors for 1, as we saw earlier in a previous question, is just 1. So the only thing that we're going to be dealing with here in terms of ratios for p to q, we're going to have plus or minus 1, and we're going to have plus or minus 13. Those are the only ones that we'll be dealing with. Again, it's just kind of a random start wherever you want to go. You can choose positive 1, you can choose negative 1, you can choose 13, you can choose positive 13. Start wherever you wish. So I'm going to choose negative 1. And as I set up my synthetic division here, so 1, negative 4, 2, 20, and also 13. I'm also thinking about my exponent. I have a 4, so all 4 of my roots could be real or rational. I might just have 2, or none of them will be. So either all 4 of these are going to work, or only 2 are going to work, or I'm going to find 2 in that list that work. So I'll run through my process of synthetic division. Seems like it's shaping up nicely here. And then negative 1 times 13 is negative 13, and I get the 0 at the end. That's really what we're ultimately looking for. So this leads us, remember, this would be x to the third now, minus 5x squared plus 7x plus 13. And the magical value that we're trying to get down to, we want to get this down to a quadratic. So at this moment, go ahead and start making my list of roots. That's how I like to process things, and I keep track of what I'm working on. So I have x equals negative 1. So I now have 3 remaining options to try. So let's just try 1. That seems like a smaller value to work with. Maybe we'll hit the jackpot here. I don't have to start with my beginning values. In fact, I don't want to. I want to pick up from where I left off with my power of 3. So I'm going to use 1, negative 5x squared, the 7x, and the constant 13. I'm going to use those values. 1, negative 4, 3, 16. No go. So this one is a no. So 1 doesn't work. So let's try another option. Let's try positive 13. And again, we'll use the 1x to the third, negative 5x squared, 7x, and the constant 13. Got a couple of 13s in there. Let's see how this turns out. I hope you have your calculators. If not, we should maybe pause this and get them. So that's going to leave us with 8. 13 times 8. 104. This seems to be running away from where we want to go. As soon as you're working with something and you get the feeling that it is not headed where you want it to be, like taking 13 times 111 right now, there's no way I'm going to get down to negative 13. So as soon as you feel like your train is off the rails, abandon what you're doing and go pick another one. You could also just go back and double check, make sure you didn't make some silly mistake. But in this situation, we're not going to get where we need to be. So let's stop and let's move on to our last option. And again, 1, -5, 7, and 13. Maybe we'll get a better result this way. -13, -18. I think I might be in the same yucky situation here. Looks like it's going to give me 237. Again, I'm not going to get back to -13 from that route. Okay, so here we are. We got a yes on our very first try. That's an awesome lucky strike. We like that. We only had 4 possible choices. The other 3 don't work. So backing up, remember that since this exponent up here, this 4, I'm either going to have all 4 of them that work, which clearly they don't, or I'm going to have 2 that work. Well, I found one that does, but the other 3 don't. So that becomes a big question mark. But what we need to remember is sometimes we can have multiplicity with a value, which means at -1 right here, this graph, however it's coming in, could be touching this and bouncing back off of it or creating a turning point. So if that's the case, that means this -1 might just work again. So let's try it one more time. So we had 1, -5, 7, and 13. Now that's a tricky thing to make sure that you pay attention to. We've tried the other options, they don't work. So now we need to think, oh, maybe that one's working more than once for our multiplicity. So -1, -6, 6, 13, aha, -13 and 0. We have what we wanted. So now we have x squared minus 6x plus 13 equals 0. So we have a multiplicity of 2 for this one. So technically that one's happening twice. So what that might look like if we broke the polynomial down, it would be like x plus 1 times x plus 1, or it would be an x plus 1 quantity squared. So that quantity squared part is where we're getting the multiplicity of 2. Now I'm going to pause this video or stop this one, and then I'm going to restart a new one just for a shorter segment on how we'll find the remaining 2 zeros. So we'll get back to this one in our next video.